scales, but we know when we do a measurement, these superpositions do not happen at the macroscopic scale. So there are different ways out of this conundrum, but Tony Nobel, who's a realist, who would not let himself impressed by theories like, for instance, the many-mode interpretation. We can talk about this at the end. He has this joke that people who believe in the multi-world interpretation of quantum mechanics should play the quantum roulette, because there will be always a universe in which they will be still alive, so they don't risk anything. So Tony was a realist, and for him, showing that on some scale, quantum mechanics will fail, and he chose these currents and voltages because the technology of the day was able to do that. He thought that if we would find a way that in the direction in which quantum mechanics would fail, that would solve this measurement problem, that would solve all the unease we have with the Schrödinger cat paradox.
And what I would say is one of the pleasures of working in this field is quantum information is people have tried to understand the resolution of this paradox. Now, not everyone will believe, what I think, but if you look at the book Exploring the Quantum by Hiroshi and Ramon, they talk about, a two-level system connected to a resonator bath, and kind of goes through the map and talks how connecting to the resonator bath makes the qubit kind of exponentially sensitive, and then, in essence, measures it and resolves that. Not everyone believes that, but for me, that's a very practical way to understand that. And there's a different kind of macroscopic kind of doing with the decoherence that seems, or at least for me, seems to be the answer to this.
Yes, but many people think that this doesn't resolve the problem of choice, that in any given experiment, one of several alternatives is chosen. That remains a mystery. And I was really happy this summer to attend the conference. This was the Angolan conference, which was organized to celebrate the 100th year of quantum mechanics, the 100th anniversary. And for the first time, I saw people in plenary sessions say that quantum mechanics was incomplete. This was the kind of thing we would discuss in front of a beer in a cafe outside the conference, but no one would dare say something like this. When we were learning quantum mechanics, it was really like a revealed truth. You learn this as something that was descending from above, and there was no way you should question that. This is why also what Leggett was doing was so outlandish.
So for our hike this weekend, I know what we're going to talk about for 2 hours. Okay, this is great. I'm glad.